to the next slide, please. But maybe I'll start with the introduction of why is a company with Cambridge in the title in the Newport region. Cambridge Glasshouse Company and HOK Engineering merged 20-30 years ago and were two glasshouse builders. But ensuring that our customer bases knew who we were, we became Cambridge HOK to keep that through. What I thought I'd do, if we can move on to the next slide, please, is I'll give maybe a bit of a plotted history of the business and some of the firsts that we've achieved over the last decade, really. Horticulture and horticultural engineering has really gone through quite a transformation in terms of the technology that we use. And in the UK, we've been at the forefront of that. That really started off with the integration of the LED light, allowing us to grow crops more cost effectively over the winter period in a greenhouse, and being able to produce production that we may have imported from elsewhere in the world, to becoming viable across the world. We started this working with Signify, or Philips Lighting, as you may know them, back in 2011, and that really started to transform what we can do in glass houses. Alongside that, we have our own factory in the Newport area, where we will build and manufacture all sorts of different units, from glass houses to vertical farms to Victorian glass houses, benching, all sorts, anything related to growing plants. You can see in the bottom right hand side a container that we built as an indoor vertical farm. Back in 2014, we were one of the first companies in the world to build containerized units, and we've shipped them all over the world. So being able to grow crops in an indoor growing facility. In 2015, we built the UK's first vertical farm, and you can see a sort of picture on in the middle of the three on the left hand side. A vertical unit growing crops on multi-layers under high levels of climate control. So instead of being able to grow maybe 1 or 2 crop cycles outdoors for a lettuce, we can get through 8, 9, 10 in an indoor farm and keep the same climate and the same consistency throughout that. Now, some of our units, and particularly indoor farms and even glass houses, now have started to become bigger and bigger energy users. Over the last 5-6 years, we've now installed 70 megawatts of capacity, producing both heat, CO2 and power. CO2 often seen as a bad thing nowadays, but actually vital for growing plants. So we take the CO2, we put that into greenhouses and vertical farms, and we help use that to increase the yield of crops. We started to move internationally with our vertical farming facility. We've got our first vertical farm in Iceland in 2018 internationally. We've then moved on and built fully automated, ready-to-eat facilities. What does that mean? It means from a seed being sown to the lettuce or watercress or basil being packed, no humans touched it. That creates a very clean growing environment where we're not using pesticides, we're avoiding washing processes, and we're able to get a different quality product to the consumer. And not to forget our origins, and we started out as a glasshouse business in 2020, and you can see a small picture there of a project where we were given a field, and in-house we have our own civil, structural, mechanical, electrical, irrigation, control and project management engineers, and we built a packing area, and that is 6 hectares. So think about 6 football pitches of glasshouse that James Dyson is now using to grow strawberries, supplying the major retailers. You'll find them in Tesco's and Marks and Spencer's in certain parts of the country as it stands. And we've also really transformed the business and put a bit of focus into the cannabis market for medical use, partnering up with Savills, Hanway Associates, and we created a turnkey brand called Crop 17, which we're starting to really build and help people enter a complex legislative marketplace where we are growing crops under pharmaceutical style conditions. And all of that has been developed with the know-how of our engineering capability, investment in new technologies, in new areas. And last year was a record-breaking year. We hit over 30 million turnover, and actually became part of a large horticultural engineering group in the country. Next slide, please. What I thought I'd do, I'd just touch on some of the pictures, some of which you can see, but a bit clearer here, and give some sense on some of the other projects that we do. So the bottom left-hand side, we also build glass houses for research units. So that could be for horticultural research, it could be for GM research, pollen, pests, where we're building glass houses on very high level of control, where we're making sure that no external environments are entering them, and helping the UK really pioneer some key research in this area, is working with large-scale university and research institutes. The picture in the middle is actually our first vertical farm that we built in London. Still very proud of it, but you can see the technology moving on and the number of layers moving on in the one in Iceland above. And then a well-known project I thought that touches on some of our engineering capability is the Eden project. We install and manage all the control systems for the Eden project, so making sure that they right climate in each of the biomes, and that the 52 different systems that are used to control the climate are all controlled independently. We've won awards, and we stripped out over 30% of the energy cost for the Eden project by simply putting in good control systems and managing that well, with the vast majority of it actually built in our control panel shop in our factory in Newport. So a wide range of activities, and we felt embracing technology has really helped the business over the last 10 years, be at the leading edge of horticulture in the UK, but we're also seeing increasing presence and taking that international in an industry where technology is key to the long-term sustainability of the food chain, as food in field becomes increasingly challenged through climate change, and we simply don't have enough land, and we need to reforest parts of the world. These high-tech ways of growing are likely to be the future for many crop types.